So welcome back to my YouTube channel, Becoming Sudeep. So today we are going to solve DSA question number 5. And so without wasting your time, let's start the question with the quote for the day. We have all got both light and dark inside us. What matters is the part we choose to act on. That's who we really are. So yeah, this is a very famous quote written by J.K. Rowling. You guys have heard her name. She is the very famous writer of the story Harry Potter. I am a very big fan of Harry Potter movies. I have been watching it since childhood. So, okay. So, without wasting any time, let's get to the question. So, yeah, this is our question. Let me read code number 169, majority element. So, you must keep your pen and paper ready before solving any DSC questions. So, yeah, let's first read what the question is asking for, and thereafter we will code. So, yeah. Given an array nums of size n, return the majority element. The majority element is the element that appears more than n by 2 times, okay? You may assume that the majority element always exists in the array. Yeah, okay. So ये तो शुरू होते ही खत्म हो गया वाह इसमें मुझे तो पेन पेपर चाहिए ही नहीं पेन पेपर फिर भी जरूरी है if we're gonna solve it think before solving any question the question might look easy but in order to write it in a more optimized way you need to think and the more you think the more optimized code it will bring to you. So yeah, here a nonce area is given with size n. We have to return the majority element. Here it is told that any element whose value is more than n by 2 times. That means that half of the array length. Then it will also it is a majority element. So yeah, we'll first check out the example with 3 is the majority element. But 2 of course first time 4 times. So here 2 is the majority element. So yeah, let's code then. Mhm. At first we initialize the length with to num to n. Hereafter we run a loop from 0 to n. Another loop inside it for comparison purpose, but we also run from 0 to n. And thereafter we compare if any of the nums of element is equal to the sub I. Thereafter we increase the count to by 1. So you take a count wherever and initialize it 0. Count plus plus. Thereafter we also check if the count value is greater than by 2. Then we return the majority element. And at last we return -1 if there is no element present in the array. So yeah, let's run this code and check. Yeah, all our test cases are passed. This is basically a brute force approach. So yeah, our time complexity will be in square and the space complexity will remain constant. So yeah, let's see our code. We are gonna solve it in more optimal way. In this second we are using sorting for that. So we're using a sort function, sorting the nums array, and we return nums of by 2. We initialize the array length to n. So yeah, this is the only code. This code is completed. Oh, yeah, sorry. Put the semicolon inside the square bracket. So yeah, this is the code on the test cases passed. Here the time complexity will be pretty less. It is log and log n, and the space complexity will be constant. So this is basically a sort function. Here we are using inbuilt sorting. As here no such exception is given that you can't use inbuilt function. So you can use if there is a condition that we cannot use sorting function, then we'll be using a more we'll be using it in a more optimized way. So here we will be using Boyer-Murray's algorithm. In this algorithm, we wanna check. It's a basically algorithm in which the voting system works. It's it provides us the voting so that voting system that we can judge which candidate, if there is two candidate, then we can compare them with their votes and just check their votes so that we can decide who whoever wins the election, we will give them an output. So here the winning element will be the majority element. So yeah, let's go initializing the relevance to n, and we'll take a candidate not to 0, and if you vote with 0, initializing. Uh, so we'll be running a for loop from 0 to n, and here we will be checking the if there is any candidate votes equal to the nums elements. Thereafter, we will increase the count by 1, else we will decrease its count or decrease in count, because if if you are not giving to one cell, there are two candidates A and B. Suppose you are giving your vote to A, so the A's vote will increase by 1, and but the B's vote will be decreased by 1. So here that's why we are using minus minus count minus minus. Here also we'll take a base case. If candidates go to 0, therefore make a new candidate and assign the nums value to it. Here the candidate it will be count. Okay. And and finally we'll be returning the candidate as the output. So yeah, let's run. So yeah, our all the test cases are passed. We have worked out. Yeah, the time complexity will be of n, and the space complexity will remain constant. So yeah, this is the Boyers Mure voting voting approach. Here we'll finally submitting the code. So yeah, our code is submitted. So yeah, with this our day 5 DSA question is completed. Next we're gonna solve another DSA question tomorrow. So till then, don't forget to subscribe my channel. Thank you.